be 120 tons in any water in which it flows. So the buoyant force will always be the same as the weight, so long as it displaces the same amount of water. The next question: a lobster crawls into a bathroom scale submerged in water. Compared to its weight above water, its weight while submerged is, remember when we were talking about the experiment, we did the measurement. We were able to find the mass of an object when it was in air, and compare that to the mass of that same object when it was in water, and we explained that the mass of the object in air was higher than the mass of the object in air. That's when we're talking about buoyancy. So in this case, if the lobster is in water, we're expecting it to have a less weight than when it is in air. So the answer there is A. Now the next question: buoyant force is greatest on a submerged 1 cubic centimeter of, they say, iron, lead, aluminum, or the above. Now the catch here is 1 cubic centimeter. 1 cubic centimeter implies that they have the same volume, and therefore for the same volume we should expect the same buoyant force. So because it's 1 cubic centimeter of iron, lead, and aluminum, we should expect them to have the same buoyant force, and therefore our correct answer there will be D, all of the above. Now, as a weighted air balloon sinks in water, the buoyant force on the balloon, A, becomes less, B, remains the same, C, increases, and D, no longer acts at sufficient depth. Remember, we bring the same thing we've been talking about. So we have an object, it has a certain weight acting on it, and there is buoyant force acting upward. Now that is the case we have, and we explained that if the weight is greater than the buoyant force, then we expect that object to sink. Otherwise, we should expect it to float. Now in this case, they are talking about the air balloon sinking, and if the air balloon is sinking, it means the weight is very great compared to the buoyant force. It means that the buoyant force will automatically become less since the air balloon is sinking, and therefore our answer is A. When swimming, there is a buoyant force on you. Is there a buoyant force on you when you are not in water? Remember, when we're talking about buoyant force, we talked about fluids, right? And fluids will mean both gases and liquid. So if buoyant force is acting on you when you are in a liquid, like in water, then you should expect buoyant force acting on you when you're in gas. The only difference is that the buoyant force acting on you when you're in gas should really be small. Because the air that is acting on you is really small. The displaced air is very small. So the answer there will be B. When you squeeze an air-filled party balloon and reduce its volume, you increase it. Now we are going to look at the definition of what density is. So they are talking that the question talks about reducing the volume. So we have to find a relationship that kind of links maybe three different variables together, and the only relationship we can find is a relationship between density, mass, and volume. Now from the density mass volume relationship, we see that the density is directly proportional to the mass and inversely proportional to the volume, which means that if the volume reduces, the density is going to increase, and the same thing happens if the volume increases, the density is going to decrease. And our question talks about reducing the volume, and we've said that if you reduce the volume, what's going to increase? The density is going to increase, and therefore the answer there will be A. When water in a brook or a system of pipe flow from a wide region, the speed of the water in the narrow region does what? Remember, increase, obviously. And I explained this in the lecture notes, and remember we considered a certain example like this, and we had fluid flow from this, and we said at this point it speeds up and then it reduces the speed. That's what we actually explained. And remember, we had region 1, region 2, and region 3. So the answer there is that the speed of the water in the narrow region becomes more, it increases. and that's part of the Bernoulli's principle that we we talked about. Now, two cans are placed apart on straws. When air is blown in between the cans, what will they do? Now, you remember the example I explained when we were talking about the Bernoulli boats. Now, remember, if air is blown, if you blow air between these two cans, what's going to happen is that you're going to reduce the pressure between those two cans, and therefore the external pressure here and the external pressure here will be higher than the internal pressure between those two cans. As a result, the pressure pushes the external pressure pushes on the can, and this other one pushes on the can, and at the end we have the can moving towards each other. So the answer there is they will move towards each other, which is C. The next question, airplane flight best illustrates what? Generally it should be Bernoulli's principle, right? Bernoulli's principle. And that is the end of the slide. I just want to say that tonight we have a meeting. It's 6 o'clock. It's 6 p.m. in the evening, and we'll be talking about videos 1 through videos 3 of the lecture on fluid mechanics. I hope you have to make sure that you are able to be there, and you have all the tools to be able to access the discussion group. So hope to see you there, and you have a wonderful day. Bye bye.